Right, I'm getting lots of questions about the abstract assignment for 103, which is due on I think it's the 13th of December. And specifically, how do I deal with my own data that I've taken in the lab to generate a scatter plot and to calculate the LD50 values for each of my strains. So we're gonna blast through that now as an example. I'm going to use the model data that has also been provided. So if for whatever reason you've got a data set in the lab that just didn't work out, that's sad, very sad, but it's a reality of being a scientist. If you were in the lab as a scientist, you would do that experiment again. In fact, you do it a number of times probably. We don't have that opportunity. That's why we've given you the model data. So if your data is good, by all means continue. If you're not happy with it, use the model data. So I've taken this data, which is on the Canvas page, in the week, I think it was 9 section, and I have taken this out and I've actually translated this into an Excel spreadsheet. Okay, and instead of doing it as 2 separate tables, I've got a single table with 3 columns: dose, strain type, and counts per plate. I've then exported that using File, Export, Change File Type, CSV, Save As, and I've exported it to a CSV file, which I've saved in a project folder for RStudio that I've already created. I've already created a project in RStudio, and I've exported it to that project folder, which I've called a yeast model. Okay, there's the data. You can see it as a CSV. Right, so we're now going to blast through this. I'm going to create a new script file called, I'll just call it model, right, because it's working on the model data. Let's read the data to begin with. And I'm going to read that to a variable called yeast data. Read.csv is our friends, and the file is called model_data.csv. There we go, I've read it. The next thing I want to do is I'm actually going to split, this is slightly different from the book. I'm going to split data into separate data frames for the wild type and mutant, which I'm going to refer from here on in as mut, M-U-T. Okay, so I'm now going to create 2 separate data frames by subsetting my original yeast data. Right, I'm going to call these 2 things WT data, that's the wild type data, and I'm going to take my yeast data, oops, and can you remember how to subset? Square bracket time, yeast data, $ strain type. So this is my conditional statement in here, double equals WT. Don't forget the comma before the bracket. Okay, you need to get all the rows as well. So what I've done here is I've subsetted my data frame, and I've used a conditional statement that I only want the rows which have WT as the strain type. Control and enter. Actually, I'll just show that to you quickly. Okay, I'm going to cough a second. Hang on. Okay, so this is my my first data frame now for just the wild type data. There you go. Let's do it for the mut data as well. Yeast data, conditional statement, strain type equals MUT, comma. Right, there's my second. Okay, so far so good. What's the next thing I want to do? Well, I haven't copied, I've only copied, if I show you this data, I've only copied the first 2 columns here. I haven't calculated the survival or the log of the survival either. I'm going to be brave and I'm going to do it in R. So let's calculate percent survival columns. Right, so for the WT data, I'm going to define a new column called survival, and I'm going to create that from WT data. Oops, WT data. I'm going to create it from my counts per plate, which I'm going to multiply by 100 and divide it by the first value in my row. So that is going to be 160. Okay. Now I could type 160, but that's cheating, isn't it? So I'm actually going to call it using the data frame, wt underscore data counts per plate gives me the column. And then, I've gone out of room here. If I do open square bracket 1, close square bracket, that will get the first value in my column. So I've then got a survival column, which is scaled according to that first value. Let's have a look. Sorry, WT data. There you go. So I've now got my survival percentages in there as another column. Fantastic. Let's go back. Let's do the same for the mute data. Create a new column called survival. Whoops. Mute underscore data. Counts per plate again, times by 100, divided by mute data counts per plate. There we go. I've done the same for that one. Let's just make sure we're okay. Yes, there it is. Okay. Now, let's take the log of both of those columns. Calculate log survival columns. And to do that, I'm going to do exactly the same thing, pretty much. WT underscore data, create a new column called survival. Actually, sorry, log underscore survival. And this time I'm going to do log 10 WT data $survival. That'll create a log column. Same for the mute data. There we go. Right, I'm going to ignore this error. It does this sometimes. I don't know what this means, but yep, there we go. We've got log survival. We know we're right because the first value is 2, because the log of 100 is 2. And the same for this one. Okay, we're looking good here. We could probably start to plot something. Shall we do it? Yeah, okay. Let's generate our scatter plot. Give ourselves some room here so we can see what we're doing. Right, now the way I did this in the book was very straightforward. I used the plot function, and the first thing I'm going to do is plot my wild type data. So my plot function is first of all going to take 2 arguments. That's going to be the X data and the Y data. My X data is the dose of the wild type. And then, comma, my Y data is going to be WT data. And I want to plot the log survival. I can hit Control and Enter there. Okay, there we go. It's done a good job. It's a bit messy because it hasn't formatted my my labels for my axes. And actually, I don't want circle. I want the circles to be for the mutants. So I'm going to use a different argument to set these circles as kind of filled in black. So to do that, I'm going to use PCH equals 16. That'll give me nice black circles, I think. Yep. I also want to make sure I've got my axis labels there. So X label equals dose millimolar, but put the unit in as well. That's important. Y label equals the log of the survival. And I'll even put the unit in there in double brackets. There we go. That looks a bit better, right? What about the mutant data? Right, to do that, I'm going to use another variable, another function called points. And I'm going to feed it again my X data for that data frame, dose, and then mute data log survival. There we go. There it is. It's in there. Okay, and that's all I need to do here. Now, if you're doing this on your own data set, you may need to, or you may wish to fiddle about with these scales. Okay, now you can do that in your plot function by setting your xlim and your ylim as vectors. So I could go from 0 to, I could put this to 500. I don't really want to do that, but it'll scale it accordingly. Or I could do ylim equals, let's say I wanted to go just between 1 and 2. Oops, sorry, C, 1 and 2. It would do that as well, right? So your data might not look as nice because you've got a scaling problem. So if there is one of those, you can use the xlim and the ylim arguments to change those. Okay, I've shown you that. Right, want to plot. Yeah, there we go. Right, a couple of things to do. I want a legend. So legend, and I'm going to put this in the top right. And I'm going to specify the labels in my legend are going to be C, there's my wild type, and there's my mute. Okay, and I also need to specify, if I do that, it'll have a go, but it won't put the dots on. So I also need to put another vector in here for PCH, and that's going to be 16 and 1. There we go. Okay, so there's my legend. Right, so my graph's ready to go. I'm missing something. I want to put my lines of best fit on here. So this is, you know what time it is then? It's linear regression time. Okay, linear regression time. So I'm now going to create linear models for both of these data frames, and I'm going to use those models to add my lines, and then lastly I'm going to use those models to calculate the LD50 values as well. So let's do that very, very quickly. Let's create a variable called WT model. Okay, and I'm going to use this LM function. I'm going to feed it the Y column label, which is the log survival, and then I'm going to use my tilde, which is like a wiggly hyphen. I'm going to do dose, and then I'm going to put a comma, and I'm going to feed it the data frame it needs, which is WT underscore data. Oops. Okay, that's the first one done. And let's do mute model as well. LM log survival dose, exactly the same data, except I'm going to change the data frame this time to mute data. Control and enter. Okay, I spelled survival wrong. Survival. Control and enter. Okay, I've got my models. I can look at those if I want. In fact, you should look at these. WT model. Right, let's have a quick look-see at this. So I've got a really strong linear fit here. I've got a very high R squared, which means that most of the dependence in the survival is attributable to the dose, almost 100%. And I've got a p-value, an overall p-value for the linear fit of way less than 0.05, which means that I really can, model this linearly. You can see the same for the mute model. There you go. Similar story there. In fact, it's an even better fit for that one. Now, you are probably, if you're doing this on your own data, you are not going to get values as good as this. That's okay. Don't be upset. What I would say is if you do get p-values that are less than 0.05, just carry on, right? Make sure you, perhaps in your abstract, have some sort of discussion about those p-values. By all means, quote them. If they're less than 0.05. If they're not less than 0.05, for whatever reason, you got a lot of scatter, maybe there was a lot of experimental error, or maybe there was a mistake in your data set, and it's not less than 0.05, then you really need to accept your null hypothesis. That is that there is no linear relationship between dose and log survival. So you shouldn't really continue at that point. You certainly shouldn't then go and calculate an LD50. So if that happens, you got two choices. Either you do a really good job of discussing why your data doesn't subscribe to a linear fit, and you can describe the limitations of your experiment, what you do again to fix it, and look for that linear relationship in future. Or you can use the model data set, which I've just shown you, you're going to get these linear fits in. Okay, completely up to you. Just make sure you do a good job of describing these linear models and their outcomes in your abstract. Okay, let's get these lines of best fit on. Add lines of best fit. First of all, AB line. Let's just throw in the WT model. Okay, there's one. Mute model. Oh, sorry. AB line mute model. There's that. Right, last thing, calculate LD50 values. Okay, so I've actually updated the book recently because I think I may have made a mistake when I was teaching you this. There's a simpler way to calculate the LD50 value, which doesn't depend on the intercept. You can do it exclusively from the gradient. Okay, the formula is in the book. Go and look at chapter 9. I think it's section. Sorry, it's not chapter 9. It's section. I've got it here actually. Let's have a quick look. Yeah, sorry, chapter 7 and 7.1.5. Use this formula to calculate your LD50 value. Let's do it here. So I'm going to create a new variable called wild type WT LD50, and I'm going to do that like this: log 10 open bracket 1/2 divided by, I want to divide it by the gradient of my slope. How do I get the gradient from my slope? Well, I can get it from my model. WT model $ coefficients. It's the second coefficient. Okay. Hit Control and Enter. It should pop up here. So I've got a LD50 for my wild type, which is about 56.2 millimolar. Wonderful. Okay, that sounds about right to me. You're going to get if you're talking to each other, you're going to get a big spread in these values. Okay, there's a lot of error. But for this model data, 56.2, let's do the same for the mutant strain LD50 log 10 1/2, whoops, divided by MUT model coefficients 2. There I've got 17.8, which I know is correct. My LD50 from a mutant strain is much lower. Okay, you're going to get all sorts of values here. It doesn't matter if they're different to this. Be honest, quote them, and include them in your abstract. That's absolutely fine. Okay, right. What was the last thing I wanted to do? Okay, yes, there are a few instances where this is not going to go as smoothly for you. And I'm going to describe 2 of those things now. The 2 that I'm getting loud and clear from everyone are these. Number 1, in your data, let's go and look at the original data again. You have got a scenario where your counts per plate for your control is actually less than the counts per plate at the first couple of doses. Okay, now that's fine. That's expected. You might get some variation due to whatever some systematic error in the lab that might mean that your counts per plate for your first couple of doses beyond the control are actually higher than they were for the control, which technically means you get a survival of more than 100%, which doesn't sound quite right, but it's okay. So if that happens, just proceed, just carry on, right? That's absolutely fine. The other scenario we have is that we don't have control data. For some reason or other, your control data's gone walkabout or you've messed it up, but you still really want to use your data. Okay, now I am going to advise you in that scenario just to remove the control data, okay, and just to carry on as follows. That means it will actually take the first value you get for your first dose as your control, and it will basically normalize your survival to that value. Okay, now it's a bit naughty, but it shouldn't make too much of a difference to your linear fits. So I would proceed as normal if you don't have your control data or something went wrong with your control data. There's a final problem that I'm seeing, and that is in instances where, and actually we're going to do this, I'm going to tweak our data. We're getting data where we get a 0 count for our plates. Okay, now that's a problem because remember what we're doing to this data. We're calculating a survival. So 0 divided by 100 or any other number is still 0, so that's okay. But you can't take the logarithm of 0. No, not in this universe anyway. That will give you an error, and that means your model won't work. You will get an error. So actually, I'm going to update that, and I'm going to show you what you should expect to see if you try and source this again, yeah, you're going to see an error when you're creating. So on the mutant model here, where I just put that 0 count in, even though everything up to that point has been fine, in fact, I can show you the mutant data. It's calculated, there you are, there's a minus infinite error in my log survivor column. So it's done that, and it will still continue to plot, but when it comes to creating your model, you're going to get this infinite error, okay, NA, nan, infinite in Y. So in that case, you don't want to include this line. So you've got a couple of options. You can either just delete it, or you can be, you can do a proper job, and you can, on the second line here, you can do something like subset your entire data so that, how would I do this? Yeast data counts per plate is greater than 0. And what that will do is it will remove, in fact, I can show you that. Oh, I spelled yeast data wrong. Yeast. There we go. There we go. So there shouldn't be any zeros in here. No. Which means when I source it again, I'll get the same result. You'll notice my LD50 has changed for my mutant strain, and that's because I took out that 0 data point. I'm not sure what's happened there. Let's source that again. There we go. Right, and that's it. If you've got any further questions, stick them in the workshop channel. I appreciate this is a long video, but I wanted to do a thorough job, and I look forward to reading your abstracts. Actually, I probably won't read them. It's going to be the marking team for the lab side of the module that's going to mark those. But if you can get this graph in, remember, you can export the graph, figure caption below the graph, don't want a title above it, don't do it, I'll find you, and make sure it looks boss in your report. Okay, good luck everybody, and if I don't see you, have a Merry Christmas, okay?